Anybody? Same photo.
लंच टाइम की वीडियो सर भूल गए चेक करना।
Okay, so all are to forget to change. Okay. Okay, I'm sharing the one more
ड्रेस है
thing.
सर ये।
Okay, dress. Okay, in the last lecture we have started the curve tracing, but one of your classmates asked me why the asymptotes there is no asymptotes. I'm just telling about this one. I think she is present now. Okay, I'm not getting that name exactly.
Yes, sir.
Okay, see this equation 2a cube minus this. We can also write these equations y cube, sorry, y power 4, y power 4. We are taking minus sign, minus 2ay cube plus a square x square is equal to 0. So as we see, to find the asymptotes, so what we do, we take the highest degree terms. So in this case, the higher degree terms is y to the power 4. Okay, this is the only one term. Now we equate to this one. Coefficient is what? 1. 1 is equal to 0. So we are not getting any asymptotes. Okay, so highest degree term is what? Y to the power 4 and its coefficient is 1. So we will not get asymptotes parallel to the y-axis, and there is no terms of variable x containing the highest degree. Okay, so there is no asymptotes parallel to x-axis in y-axis. So one thing is clear from here.
Yes, sir.
Okay, um, what we write, coefficient of highest degree of y is equal to 1. Okay, so this is the constant, not variable of x and c. You can write here, which is a number. Therefore, no asymptotes parallel to y-axis. And similarly, coefficient of highest degree of x is equal to minus a square. So minus a square is equal to 0. So this implies that no asymptotes parallel to x-axis. Okay, so these things you are getting. Now we come to the oblique asymptotes. So in oblique asymptotes, what we write the highest degree. term which containing the combination of x and y variables. So function of x, y. Okay, the highest degree means the term is y to the power 4. So this is y to the power 4. That means x to the power 0. Okay. And this, so highest degree means 0 plus 4 is 4. This is 5, 4. Okay. Similarly, 5, 3 of xy. So what we can write, minus 2ay cube minus 2x to the power 0 y to the power cube. Similarly, phi 2, the second degree terms, phi 2 xy is equal to, is what the things, minus a square and y to the power 0. These are the terms are given when we find going to find the oblique asymptotes. Okay, so now we write in the auxiliary expressions. That auxiliary expression, we take the x is equal to 1 and y is equal to m. So y, this is m is equal to m to the power 4, and phi 3m is equal to minus 2am cube, and phi 2m is equal to what, minus a. There is no m because y to the power 0 and x is equal to 1, that means minus a. Okay, after that we are equating this highest degree terms equal to the 0 to find the roots of this highest degree terms, means value of m. So m is equal to repeated 4 times. Okay, so that means there are 4 slope value is 0, 0. There are, there is, could be 4 asymptotes on the basis of this value. And what we need to find the value of c. So there is the formula, c to the power 4. We need c 4c. Okay, so by quadratic equation we have to form for the c value intercept. Okay, we already written for the 2, when the roots are repeated 2 times. So c square upon factorial. So here roots are repeated 4 times. So c to the power 4 by. So highest degree terms is what, 4m, and this is the 4 times derivatives. Next, c cube factorial 3 and phi 3 triple dash m plus c square factorial 2 and now phi 2 double dash m. And next is c upon factorial 1, and this is 4 3 2. Next is 1 sorry, 1 dash only m, and last one is phi naught m is equal to 0. Okay, so using this expression, we need to find the, for m is equal to 0 only, so we need to find the, there are 4 values of c. Okay, now when you put the values, when you differentiate 4 times phi 4m, so what it's become? Okay, you see this is the things is here. When you differentiate m to the power 4 with respect to m 4 times, what you get? The value. Anybody?
24.
24. 4 times derivatives. Anybody else? 5.
Yes, sir, 24.
Okay, factorial 4 into 24 plus c factorial 3. In this case, phi 3 double dash
12 minus 12.
minus 12a. C square factorial 2. How much we get? 2 times derivatives?
0.
0. And others are not That is 0 and 0. Now you see these terms, this expression is independent of m. Okay, it's not depends upon because we have to take m is equal to 0. Okay, so which is the independent of this m. Okay, so that means there is no asymptotes. So we need to write which is independent of m. Therefore, there is no oblique asymptotes. Hence, there is no asymptotes.
Sir,
Yes,
sir, in the exam, do we need to show this that there is no asymptote like by writing all these
if
things?
you show this is good, no issue. Uh, just you write the line at least because when parallel to y and axis is it is easily visible by the
Yes,
expression.
sir. Yes, a
But
constant term.
for the oblique, you do something, it's better for you because okay, because already I discussed an asymptote, so that's why I'm directly writing here. Uh, okay, so now okay means in the next the curves, tracing of curves, we will not do all the things, but for oblique you need to do something. Okay,
Okay.
if there is asymptotes, you write the parallel to y, parallel to x is in this manner you can complete. Okay, now we are coming to the next problem. So we have done the curve tracing for this one. The curve tracing next trace the curve a square y square equal to x square a square minus x square. Okay, a is the here parameter. Now see in this curve, okay, you can solution given a square y square just a second. Yes, I'm taking class. Okay, taking class. Okay, same thing is a square x square minus x to the power 4. So it is question number 1. Okay. Solution. So first we are going to write the about the asymptotes. Asymptotes not symmetry first. Symmetricity. So we see that uh, the curve is symmetrical about the x and y axis because the curve contains even power of x and y. Okay, in one sentence we can complete it. The curve is the given curve. You can say the curve is symmetrical about x and y-axis as the equation of curve as the equation of curve contains even powers of x and y. Symmetricity is completed. Second one, after symmetry, we focus on the origin. Okay, is it the curve is passes through origin or not? Okay, so obvious this satisfy the when we take x is equal to 0, y equal to 0, and this equation of curve does not contain any constant term. Okay, so we can write second, this is first one, origin. The curve is passing or passing through origin as the equation of curve does not contain constant term. And third, now we see the tangents at the origin. Okay, tangents at the origin. So in the tangents at the origin, how we find tangent at the origin? In the last lecture,
Equating least power term to 0.
least power of lowest degree term of equations. Okay, so we see in the lowest degree term this 2 and y(x) square. So when you write one side, okay, so this is the y square minus x square. So lowest degree term of equation 1 is a y square e square minus is coming 3 square x square is equal to 0. This implies that is we remove because is here greater than 0 means what the value of a plus or minus always positive, no issue. So next we write it equal to 0. This implies that y is equal to plus minus x. So therefore y minus y plus is equal to 0 and y minus equal to 0 are asymptotes, not tangents tangents at the origin to the curve. Fine. Now the last one, the double point or multiple point, means ordinary point or singular point. Ordinary or what we say multiple points. Ordinary, or we can continue with this one. Notion point or multiple points since there are two tangents. These are two. Yes, sir. गुड आफ्टरनून. हाँ हाँ, मैं भर दूंगा. अभी मेरी क्लास चल रही है, क्लास के बाद में कर देता हूँ. हाँ, क्लास के बाद. ठीक है. हाँ, क्लास के बाद मैं बता दूंगा, है ना. हाँ, ओके. There are two distinct tangents. There are two distinct tangents at the origin to the curve. Therefore, the origin is what we called node, cusp, or isolating point.
Sir,
Node, cusp, cusp or node.
So node.
Node, cusp, that means when the two tangents are repeating. Means in the last curve, tangents are coincide each other. So the origin is known as is called node. Node. Okay. So node is correct. N-O-D-E or okay, fine. We can also write the nature of origin is node. Okay. The origin is called node. It's better to write the nature of origin, therefore, or the behavior of therefore the nature of origin is node. Okay, it is very important. That is double point. It is next fourth, fifth. What we do next? Intersection with the coordinate axis. Intersection with the coordinate axis. So x is equal to 0 in equation number 1. This implies that y square is equal to 0. This implies y is equal to 0. That means curve is intersecting y coordinates at the origin only. Okay. So this implies that the curve intersects to y axis at origin only. Okay, y is equal to 0 in equation 1. This implies that when y is equal to 0, see the term y is equal to 0 means x square a minus x square. A square minus x square is equal to 0. So this implies that x is equal to 0 and x is equal to plus minus a. So the curve is intersecting y-axis. Therefore, the curve is intersecting y-axis. Sorry, x-axis. X-axis at so we can write like this manner: coordinate points minus e0, 0, 0, and 0, a. Okay, just clear. So far, we observed that symmetrical about the x and y axis. That means when we draw the curve in first quadrant, similar there, what symmetricity we can draw in the fourth quadrant. And when symmetrical about the x-axis, symmetrical y-axis, when we draw uh, the curve in the first quadrant, it's just symmetric. The curve drawn in the second quadrant symmetrical means of that first quadrant, and similarly third, second and third is the symmetricity. Symmetricity passes through the origin calling x-axis is intersecting at 3 points, and tangent, there are two tangents we are getting. Okay, two tangents at the origin. Now we check the what asymptotes, fourth number. Sorry, fourth is not, sixth. Asymptotes. So given expression is what we can write one side a square y square is equal to x square. So this implies that we writing one side x to the power 4 minus a square x square plus a square y square is equal to 0. Okay, so see here. Hmm. So highest degree term of x is coefficient is 1, not parallel to asymptote is not parallel. We will not get the parallel to x-axis. And highest degree term y square is there. Coefficient is a square is constant. We will not again get the asymptote which is parallel to the y-axis. Okay, now when we talk about the asymptotes, oblique asymptotes. So here the highest degree terms phi for m is equal to 1 because x to the power y is not there. Okay, so when we differentiate it become the 0, or like that we get the independent. Okay, the term will not get the phi 4 and the second degree terms. The second degree terms we are getting phi 3m, there is no term, and phi 2m we will have like minus a square m. Okay, so in this case not possible because highest degree term we need to find the roots of highest degree term. The highest degree term is constant, so how we can find? So there is no chance. This you can write here, since phi 4m 1, which is constant, therefore there is no asymptotes to the curve. Okay, asymptotes we have written the with the justification. Now we come to the very important part, region of absence of the curve. Sixth, seventh, region of absence of the curve. So given expression is what? A square y square is equal to, you must write first, x square a square minus x square. So in this expression, we need to find for what value of x and y the expression is not defined. Okay, so that means the curve has no region. Okay, so we can do like a square y square and so for every value of x, what happened? Okay, suddenly it is disappearing. Okay, wait for a second. हेलो, यस सर। नहीं सर, वो उनसे भी नहीं हो रहा था, वो बोले कि रवि सर से पूछूंगा कैसे होगा। वो रवि सर तो थे नहीं आज। नहीं, स्क्रीन रजिस्ट्रार नहीं, वो सरेमाइस में जो है। नहीं नहीं था सर, वो दूसरा एक और बैठता ना, वो था, तो उससे भी नहीं हो पा रहा था। तो बोला कि मैं रवि, मेरा फोन नंबर लिया, बोला मैं बता दूंगा कैसे होगा। ओके, तो अच्छा मुझे हम्म हम्म, हाँ हाँ यस, हाँ हाँ यस सर, मेरी क्लास, हाँ हाँ मैं पूछ लूंगा। ओके सर। Okay, I don't know what happened. Suddenly disappeared. Okay, I think you understood the things. We come to the origin. First was symmetricity. Symmetricity means we have done origin Third is the tangents at the origin. Fourth one, mm, singular or multiple points at the origin. Okay, this part we have done. So I'm just at least we heading writing. Fifth one, what I've written, singular intersection with the coordinates, coordinate axis.
Excuse me, sir.
Ah, yes, yes.
Sir, your screen is not visible.
Ah, yes. Okay, okay, okay. Just a second. Okay, now it's visible.
Yes,
Yes,
sir.
sir.
Yes, sir.
Actually,
Yes,
what
sir.
suddenly on that time disappear the things what I've written. Okay, so I think you understood the steps. Only heading I'm repeat again. I'm writing intersection with coordinate axis. You do this one. Okay, so this was x-axis means intersection at minus a0 comma 0 0 and 0 a like asymptotes, no asymptotes. Okay, in short form writing nil, and the last one was in the uh, region of absence, seventh region of absence of the curve. So our expression was a square y square is equal to x square square minus x square. This implies that a square y square square a square minus x square is equal to 1. Okay. When we take x is equal to 0, so x is equal to 0, so left hand side is undefined. 0, that means x is equal to 0, a square minus x square is equal to 0. Mm. Mm. So this term left hand side means a square y square upon x square e square minus a square is imaginary if a square minus x square less than 0. Okay, When a square minus x square less than 0, so what the term is become imaginary because both sides are square root here. Okay, it's come here. So a square less than x square. This implies that x square greater than a square. So means to say when a, so x is greater than a and x is less than minus a. Okay, so in this region, the term is this one imaginary if a square minus x square less than 0. Therefore, the curve is absent in the region x greater than a and x less than minus a. So now we talk about in y. Hmm, for y, x square a square minus x square upon y square. We are not getting the proper things to find mm, the absence of region because intersecting the 3 points only is not going beyond the points x is equal to means the coordinate point on the x-axis minus a0 and a0. It will not go uh, this one. Now we can see some spatial points. In spatial points, uh, we can discuss about the rate of change of y with respect to x and the rate of change of something. What could be the rate of change? So we can consider these things in the spatial point number 8. Spatial point. So after the equations, we can write x to the power 4 directly writing minus a square x square plus a square y square is equal to 0. So now we're differentiating with respect of x. 4x cube minus 2x square x plus x square 2y dy this is equal to 0. So now, so dy dx is equal to what we can write to 2a square x minus 4x cube upon a square 2ay. If dy by dx is equal to 0, So this implies that 2a square x minus 4x cube is equal to 0. That means x2a square minus 4x square is equal to 0. So this gives you x is equal to 0 and 2a square 4x square is equal to 0. This implies that 2a square. So 2 to cancel here. A square upon 2. So therefore x is equal to plus minus a root 2. So that means a upon root 2, that is the value. Okay. The point of inflection, I think you know, when dy of x is equal to 0. So that is the point. The curve is changing its direction. And dy by dx is infinity, not equal to tend to infinity. This implies or implied by what we can write 2a square y is equal to 0 means y is equal to 0. So y is equal to 0 x-axis perpendicular. Yes, Abhishek, something. So it is the special point means sometimes it is needful to trace the curve. So in this regard, dy of dx is equal to 0. That means there is the rate of change is 0. That means there the curve is changing its directions. So that's value at plus minus a upon root 2. Okay, that's value. And when we draw to the curve, some special point, one more thing we can consider, like a square y square is equal to x square a square minus x square. Suppose we are giving x is equal to a, so y is equal to 0. X is equal to a, this implies that y is equal to 0. X is equal to, sorry, a. Means at x is equal to a point, y becomes 0. That means it's touching the y-axis, a by 2. So this implies a square y square is equal to a square by 4 a square minus 12 by 4. This implies that, so this cancel out. Now we have 1 upon 4. 4 a square upon 4 is equal to, we can write 3 3a square 4 square, this is y square. Therefore y is equal to root 3 upon 4. Okay, means a by 2. Similarly, when we take x is equal to a by 4, So we will have value like that. When x is equal to 3a by 2, you can take, so you will have some value here, you calculate, and just interesting, it is a needful because we are doing in the first quadrant. So we come to the this one. There is the two tangents we draw here, which is y equal to x and y minus x. So one is passes through in this manner with the 45-degree angle, this much, and other will go such a manner, this. Okay, and there is the 3 points here, something we can consider. This is minus a0, and this is 0a, and this is the origin. And the value of, like, at a is equal to 3a by 2. So when we draw, it is like in this manner is coming. So like, okay, same by the symmetricity. It's like leaf. Okay, unable to draw in this. And by the symmetricity, the y-axis, it will, okay, so this, it will touch tangent. Okay, so this is our the equation of curves. And here the value is like is equal to a by 2, and here a by 4. So its value is, when you compare, it's like this is the highest one, and this is the, and by that value you can get one. I not calculated by a by 4 and 3a by 2. Just calculate a by 2. This is the root 3 by 4. Okay. So there is no curve in this area when x is greater than a, and when a is less than minus a. There is no reason. But we are not getting about the y in the y region.
सर एट एक्स इक्वल टू जीरो पे भी तो इमेजिनरी होगा ना
x is equal to 0.
जीरो पे
Hmm.
इमेजिनरी हो रहा है ऊपर जो इक्वेशन 7 नंबर पॉइंट में लिखा हुआ था
x equal to 0 पे, x equal to 0 पे इमेजिनरी तो नहीं हो रहा है. It tends to infinity. x is
कर्व कर्व एग्जिस्ट नहीं ना करेगा वहां पे इन्फिनिटी होगा तो।
no, we are searching. Say this part, this whole part, when imaginary. So a square minus square less than when it is negative. A square minus square when it is negative. So what become, अब negative parts को इस तरफ ले जाएंगे. Y square x square is equal to a square minus x square x square. Okay, so when this part is imaginary, when a square minus square less than 0, Okay, so because this side for all values of x, so left hand side is always positive. Okay, but this side imaginary is not satisfying. Okay, when you say x is less than 0, so a square y square upon a square minus x square is equal to x square. So when x is less than 0, x square less than 0, so that means what? X is less than 0, but also it depends upon this one. Okay, so when you are including this one, because it's become imaginary, when a square minus x square less than 0. Okay, so this is the things here. It's not only in x square. In x square is negative, based on also depends upon this one. Because a square is there. So a square is what? A square when take the 0, so a is cancel out here. And y is again plus minus x. So only this part is important. In this case, it will become the for all values of x we can check. Okay. So similarly, you can draw one more curve. I will tell you that has some asymptote something. I'm not discuss the problem of asymptote. The next lecture we do the on asymptotes. So now you can trace this curve. Question: trace the curve y square a square plus x square is equal to x square a square minus x square. You can do it. Number one, number two, x square plus y square is equal to a square x square minus y square. And one more problem. Third number, we can trace the cissoid of Dawkins y square 2a minus x is equal to x cube. So for the curve, for this one, the curve is like this manner. Okay, it's not looking like. Just a sec. Here, like this manner, one line is passes through in this manner. Okay, so this is the curve of this one, third number. So similarly, we can draw the curve. Other one, you can try this one. This is all approximation process. Okay. Um, so generally, we asked always one question from the curve tracing. Okay, in the next lecture, we can do one asymptote scheme. After that, we start the in polar form tracing